Okay, here we go. I just want to do a quick review again of how we did this. I'm going to look over the numbers. I'll cheat because I don't remember all the stuff you were given. But I know it was about the bleachers and you were given a certain height and you were able to figure all that stuff out. But the idea was that you had bleachers. Oh, let me get, whoa, sorry. All right, so we had, so many bleachers going down, and then there was a distance from here to here and a distance from there to there that you had to figure out, and you added them all up. And I remember we said it was something like you had 0.21 times 20 steps, right? And then you multiplied that out, and I think I had the number, it was something like 4.2. I'll just do it 0.21 times 20. Yeah, you got 4.2 meters, and then you added the other distances here, and we got a distance of 5.82, but then you reminded me that you also had to add the 1.29. So everything added up, and you got, I'm going to write over here the new distance. So we had everything added up to the 5.82 was everything you added here, plus 5.82 plus your 1.29, and I get that to be 5.82 plus 1.29, and I get a distance of 7.11. All right, which is what I have over there. Okay, so double check your numbers and make sure that was what you were given, but I'm going to put a D equals 7.11 here. Okay, all right, then you had all your times, and we added them up and divided by the 10 because there are 10 of them, right? And I don't have your times still, but check your times, but you should have added them all up, divided by 10 because there are 10 drops, and we get an average time of 1.031, 1.031 seconds, and this is meters, okay? And what else do we need? So we were told that it was going to be dropped, and so if we know something's being dropped, we can say that the initial velocity, VI, is equal to 0 meters per second, and that's helpful. Okay, and we needed to figure out acceleration because we wanted to compare it to 9.8. So A is going to be what we're looking for, and we want to compare it to negative 9.8 that the textbook gives you. So we looked at the formulas, and we figured that the best formula for us to use was your D equals VIT plus 1/2 AT squared. So we have distance, I'll write it in black, D is equal to initial velocity times time plus 1/2 AT squared. The initial velocity was 0. Anything times 0 is 0, so that went away. And we just have D is equal to 1/2 AT squared. Okay, now we do a little bit of algebra because we need to get A by itself, so I multiply both sides by 2 so that the 1/2 can get crossed out because 2 times 1/2 is 1 and it's gone. So I have 2 times D is equal to AT squared. Now I divide both sides by t squared, and because we're not solving for t, we don't need to square root it. So that is gone. So now we have 2d divided by t squared is equal to my acceleration. All right, so then we divide it out, or we plug in our numbers. So we have 2 times 7.11 divided by 1.031 squared, and we cannot forget to square that value. Okay, so in my calculator, that'd be the same as writing it as 2 times 7.11 divided by 1.031 squared, like that. I'll do it in my calculator right now. 2 times 7.11 divided by 1.031 squared. And I get 13.38 basically, because it's a bunch of other numbers, meters per second squared. So that is what I calculate the acceleration to be. Now, so if we had 13.38, And it's really, we want to say negative, and that just means it's down. And your teacher wanted you to compare it to negative 9.8 because that's down also, and that's what the textbook is. What you'd want to do is you'd want to subtract these two numbers to figure out how far off it is, and then probably divide it by 9.8. So I'm going to ignore the negatives because I don't really care about those. But they both cancel out. We both know it's down. So that answer, that minus 9, the 13.38 minus 9.8 gets me a 3.58 meters per second squared that it's different by. If you divide that by 9.8 meters per second squared, you get that you have an error of 36.5%, which is pretty big, okay? So if you do have that kind of a big error, I would just say that it's probably due to the stopwatch, the timer, and everything else. I would check your numbers too and just make sure there weren't any mistakes that we made or any numbers we put in wrong. But that's how you would do that lab, and good luck.